Okay, really great to be here. This is actually my first State of the Map. Mikel, what number is it for you? No idea. Yeah, but so I'm excited to be here on behalf of the Earth Genome. Between me and Mikel here, I'm going to be talking a little bit about work we've been doing, exploring how AI can help us imagine the future of our maps through this demo toy chat assistant for OpenStreetMap data that we've created called ChatGeoPT. A little bit of background on the Earth Genome for those of you who are not familiar with us. I put the text from the website up there, but it can really be just distilled down to a message of we hope to enable positive decisions around the environment through best use of technology and environmental data. And if you want to shorten that even more, you can just say, basically, we love AI and we love maps. We love AI. Why do we love AI? Because we're on a mission to make environmental data accessible, integrated, and actionable, and AI can help make that possible. And as an example of that, we have, with the support of the Minderoo Foundation, helped create Global Plastic Watch. This is one of the world's greatest authorities on informal, large plastic dump sites across the planet. And the way this works is we use AI to scan satellite imagery and pick out these different smaller, previously untracked plastic waste sites. And and we can tell that about 25% of them are close to waterways and contribute disproportionately to the 10 million tons of plastic waste that ends up in the oceans every year. So AI is really powerful to help us make use of all that satellite imagery really quickly in order to generate these important data sets. We also love maps. And why do we love maps? Well, it's actually the same reason we love AI. We're trying to make environmental data accessible, integrated, and actionable, and maps make that possible. So you can really say maps were the original Geo AI, right? A quick example there, we are a core technical member of Climate Trace. We take all the data that's produced through the Climate Trace platform and we plot it on a map. And so for those of you who don't know Climate Trace, this is a large effort that Al Gore is really instrumental in leading about calculating emissions across the globe from the ground up and then estimating and aggregating them into actionable insights. And of course, visualizing these and interacting with them in some kind of map-based platform is the only way that we can take all this abundant amount of data and make it something that can be quickly digested and help inform positive decisions. So we love AI and we love maps. And so naturally, we've been pondering lately as AI has just exploded in popularity and across the conversation in all kinds of different communities. We've been pondering the question, how can we best bring together AI and maps? And like many of you, I think that our recent interest has been really piqued by the development of these powerful large language models like ChatGPT. I guess I was curious because I'm up here, how many of you use ChatGPT or another large language model every week in a work setting? Okay, yeah, good number. How about every day? All right, not everybody, but we're getting there. I think it's going to become increasingly common as we move forward. I'll give you a quick tip here for those of you who don't use these tools every day. It's that ChatGPT and other AI tools like Bard or whatever actually have a very well-built functional knowledge of many geospatial tools and libraries, including those listed up there. I also put some example prompts you can provide to these platforms in order to get back an answer to help you do some kind of geospatial computation or analysis that you would want to do. And this way allows anybody can be a power user of any of these tools. In particular interest to this group and what we built our ChatGeoPT assistant to work with is this last example here, Overpass QL and XML. And as a quick example here, Overpass QL, Overpass is just super powerful, right? We can query all of OpenStreetMap's data, but it's actually pretty hard to learn. And using ChatGPT or other tools, you can quickly generate a valid Overpass query. This is an example that I performed that might be relevant for everyone in this room here. Asking for ChatGPT to output a valid OSM Overpass query for restaurants in Richmond. And as you can see, I also asked for it to output a URL, a clickable URL to actually auto-populate that in Overpass Turbo. And it does a pretty decent job of helping us find restaurants in Richmond where we could go for dinner one night when we're here. And this way, anybody can use Overpass, even if you haven't read any of the docs on how it works. So we were excited about that idea, and we thought, how can we best integrate this into a tool that helps demonstrate the power of what these language models can do? And what we did is we built this Geospatial AI assistant, which is really just a wrapper around a couple APIs. It's 150 lines of code, or a little bit less, and the main magic actually happens in a set of English language instructions that we provide to the AI assistant, which you can see right there. I instruct the AI assistant to do three things. Number one, when it's prompted with a question from a user. Number one, provide a statement consenting to help. Yes, I'm here to help you. Number two, return a text of a valid Overpass API query. And number three, add a little personality. Add a fun fact related to the question, or a very funny joke or pun related to the question. And you can see I elaborated there. You can see which part I was really most excited about here. But the point is that by just providing these assistant instructions, as you can see in that diagram at the flowchart on the right side there, the assistant instructions are supplied along with the user prompt to the OpenAI API, which queries GPT-3. That responds with a textual response, which is formatted according to those instructions. We then extract that Overpass QL, which we pass to the Overpass API. The Overpass response comes back, and then we could parse that on our own, right? We could read that response and make sense of it. But I don't want to do that if a language model can do that for me. So we actually feed that Overpass response back into GPT-3, which then can read it, summarize it, and provide an answer to that original question. And this all gets fed back in a loop in such a way that you can have a chat, an ongoing conversation with the chatbot assistant in order to have an evolution of your query. Here's a quick example of how this works. Let me see if I can just speed it up. So this is, we're asking for a restaurant for celebrating grandma's birthday in near Hereford, England. And the query goes out. We get a response back from the OpenAI GPT-3 model. And you can see it does those three things. First of all, statement consenting to help, text of a valid query, and then a fun fact. Did you know the world's first restaurant was opened in Paris in 1765? Wow. So that's passed off to we pass it off to the Overpass API, response come back. In this case, there are too many restaurants near Hereford to send that back to GPT-3 to summarize, but we can iterate on that query. Now I'm asking where she loves Indian food, so let's limit it to places that serve Indian food. And right, so that's it remembers that we wanted to search near Hereford and refines that search and says, now we're just going to look for places, limit our search to just Indian food. And in this case, this time, the response can be read by the Overpass API response. We can, it's a sufficiently small size that we can parse it with GPT-3, and it gives us this natural language answer to my original query. If you're looking for a restaurant to celebrate your grandma's birthday, try these restaurants. And then I asked it just for a fun question, what's the meaning of life? And it responded with, says, I can't help you, but you saw there was a joke there at the end about maps. What did one map say to the other map? Let's just stick together. I don't know about its humor, but there we go. So the main findings of ChatGeoPT are as are listed here on the slide. LLMs like GPT-3 can be an effective bridge between human language and the language of technical geospatial workflows. Conversational chat can enhance the quality of experience. That personality is actually really something interesting to play around with. I didn't cover this in those slides, but wrote up a blog post about this as well, where we go into a little bit about this last point. The injection of built-in LLM knowledge is both powerful opportunity and a potential risk. So that's the first part of these slides. Now we're going to go pivot and look at the future and where the next phase might go with AI and maps. The first thing that I should note is I'm sure many of you have felt this, is that the pace of innovation is really accelerating. Since we built ChatGeoPT in March, lots of exciting developments have occurred, like Planet published a Queryable California, where using natural language, we can query their data and do analysis in order to learn things. Text is terribly small there, but to learn like what's the average temperature in Sacramento. QGPT, I just saw this the other day. This is an AI assistant for QGIS, where you can prompt it and it'll help you do things in QGIS that you wouldn't know how to do naturally otherwise. So those examples I've shown you so far are really just assistants, and they're wrappers around APIs. But of course, AI can do a lot more than that. And there's a lot to say about the artificial intelligence ability to have a real semantic understanding of data. And it looks like, is this going to work? Yeah. Here's an example of OpenStreetMap data, where this is something that my coworker came up with, where we're organizing OSM tags semantically in an embedding space, and then using a text query saying we wanted to know what tags existed are close to forest. A bunch of different tags come back from that search in order to help understand what kind of tags we should be looking for when we're labeling data in OpenStreetMap. Segment Geospatial is another really cool tool that was just announced a few weeks ago, I think, which uses the meta segment anything model in geospatial data, which has a semantic understanding of what the world looks like and can help just automatically pull out polygons from satellite imagery. And so what I think that the lesson really is here is that AI can power OpenStreetMap at all levels of the tech stack, from editing the map, from auto segmentation and labeling, through maintaining of the OSM database, through element monitoring and error detection, through reading the map, through these kinds of assistants that I've demonstrated a little bit today, or allowing for third-party app integration through the ability for data to flow back and forth between APIs without needing to necessarily have a lot of engineering work go into that. So that's how AI can affect OpenStreetMap. But if you turn that question around, I think there's also something really interesting to think about how OpenStreetMap can affect AI. And so all those models that we've looked at so far, like GPT-3, right? That's all just scraped from the internet data, and it's not geo-specific data. Like the image models are all trained on pictures of cats and dogs, right? Because that's what's on the internet. But if you think about where we really should be heading, and I think this is what Earth Genome, my company, is really excited about, is what if we built AI specifically around geo applications? And so in that sense, we can have OSM data be one part of the data set that feeds into a large Earth observation model, which has some awareness of what the planet looks like and has awareness of geospatial coordinates and time, and have that learn something really, the essence of the Earth through something that we talk about as Earth embeddings. And that can in turn flow back into OSM data in order to help refine that data over time. Just a quick demo of where we're just starting to explore these kinds of ideas. We're developing something called Earth Index, which allows us to search across the planet In this case, we're looking for gold mining in the Amazon, and it's just a quick little conceptual demo. But by looking for a place where gold mining has progressed and then searching across the Amazon, we can find examples of other places where new gold mining has occurred. And so we have temporal and spatial data all wrapped into these embeddings that can then be used for important geospatial workflows. And I think that is it. If you're interested in checking out the code for ChatGeoPT, it's there on GitHub. And otherwise, yeah, thanks for watching the talk. Feel free to get in touch with either Mikel or myself, and stay tuned for the work coming out of the Rich. Thank you.